Let's look at absolute value. What does that mean? Well, it's an operation that we can perform on numbers and expressions. And it looks like this. You take the absolute of some value A. You just put it in these vertical bars, and that means I'm taking the absolute value of it. What does that do? Well, let's look at a couple of examples. If I take the absolute value of the number 4, what does that do? Well, it gives me the number 4. Okay, that's not too bad. What if I take the absolute value of the number 0? What do I get? I get 0. Okay, let me try one more. I take the absolute value of the number -2. This gives me 2. Okay, so that's where the difference is. What absolute value does is it essentially throws away the negative sign. Okay, so if you have a negative sign in that original value or expression, well, you get rid of it, and then you have the absolute value. Okay, so it's not too hard. It's fairly straightforward. Here's sort of the general rule for it, right? So we're saying that when you take the absolute value of some number or expression A, well, if that is already greater than or equal to 0, then you just leave it alone. You just get A back out. But if that number was less than 0, so if that number was negative, well, now you have to get rid of the negative sign. And how do we do that? Well, we multiply it by -1, right? So negative of a negative will give you a positive. So by negating that negative number, we're just going to get essentially a positive number. So it's not too bad. Just think of it as throwing away the negative sign and you should be okay. But there can be a couple of subtleties, okay? So the operation is pretty straightforward, but what if I was to take the absolute value of an expression 10 minus 12, okay? So I want to take the absolute value of this. I can look at this in a few different ways. So one way I might want to look at this is I want to see it as, well, let's do what's inside first. So 10 minus 12 is going to be -2, and then I take the absolute value of that. That's just going to be 2. So that's one way we can do this. We can just do the math and see what we get. Another way we can do this is to think about essentially this rule, right? And so we know that what's inside here is going to be a negative number. It will be -2. So I need to essentially multiply what's inside by -1, right? So what I'm going to get is -10 minus 12. That is the same as taking the absolute value of 10 minus 12. Just have to negate it. And so if I do that, I can rearrange things here and I can make this the same as 12 minus 10. And of course, this will equal 2. So I will get the same answer. But it's interesting just to note that you can sort of get a new expression here where the terms are reversed. So that happens if that original expression is a negative value. All right, so let me show you another way that we can understand what absolute value is doing. So I want to think about absolute value here as distance on like a number line. Okay, so here's my number line. Let me draw the origin for you right here. And let's say I have a position over here. Let's say this is position 4. Okay, so this is 4 units away from the origin. And taking the absolute value of 4, well, that just gives me 4, okay? No change there because it's not negative. But I can think of this as essentially traveling 4 units to get to this location. So that's my distance, right? Absolute value of 4 is 4, and that is my distance. If I have another location, let's say over here, let's say this is -4, well, how far away is that from the origin? What's the distance away from the origin? Well, it's still going to be a distance of 4. It's just to the left, okay? So there's sort of, the distance doesn't include a direction. You sort of throw away the direction information, and that's essentially what the negative sign is doing. It's telling us what direction we traveled. But if we don't care about the direction, we just care about the distance, well, then just take the absolute value here, and that will be how far away you are from the origin. So we can sort of think of this as this absolute value is the distance from the origin to some value A on the real number line, right? So, let me just look at one more. Let's say I have another point here. Let's say this is position -7. Well, how far away is -7 from the origin? Well, it's going to be 7 units away, right? So absolute value can be interpreted as distance from the origin. We're going to have a couple of different, essentially, properties or rules that we can develop from a basic understanding of absolute value. Let's take a look at the very first one. So the first property here is super simple. It's just saying that whenever you take the absolute value of anything, you're going to get something that is essentially 0 or positive, right? You're never going to get a negative number. So if I take the absolute value of 3, well, I'm going to get 3. If I take the absolute value of -3, I'm going to get a positive number 3. If I take the absolute value of 0, I'm going to get 0. Okay, so that's all this is saying. Super simple. Let's take a look at the next property. So here, this is sort of building on the same idea. If I take the absolute value of this, I know I'm going to get a positive or number or 0. And if I take the absolute value of this again, I will get a positive value or 0. So I'm going to get the same thing both times, right? So let's say if I take the absolute value of 6, well, this is just going to be 6. And this is the same as if I took the absolute value of -6. That's also 6, right? Super simple here. Let's try another idea. Let's take the absolute value of the negative square root of 2. What's that going to be? Well, it's going to be root 2. If I take the absolute value of root 2, well, that's also just going to be root 2. Okay, so this second property is also pretty straightforward. You just always get a positive value or 0. It could be 0, right? Let's look at the next one. So this is sort of like a product rule for absolute value, right? If you take the absolute value of two numbers multiplied together, it's the same as taking the absolute value of them separately and then getting the product of that. Let's take a look at an example. How about 4 times 6? Okay, so if we do this, we can imagine taking the product first. We would get the absolute value of 24, and that would just be 24. Okay, no big deal there. What if we use this rule and instead we took the absolute value of 4 and then multiplied that by the absolute value of 6? Well, this would essentially be just 4 times 6, and that would be 24. So great, it works, okay? Not a huge surprise there. Let's try something with a negative inside of it. Let's see if that works, okay? So what if we do, how about -3 times 8? We're taking the absolute value of that. Well, that's going to be the same as the absolute value of -24. And when I do that, I'm just going to get positive 24 out. And I could do these independently, right? -3, absolute value of that, times the absolute value of 8. What's that going to give me? Well, this is going to give me 3 times 8, and that is 24. So once again, it works. So taking the products here, you're always going to get essentially a positive value or 0, right? And so you can split it up. It won't matter. Let's look at the next property. So here we have essentially a quotient or division rule for absolute value, and it looks very similar to the product rule. And we can test this out, right? So the idea is if I have the absolute value, let's use something with a negative sign, right? So if I have the absolute value of -18 over 3, what am I going to get? Well, one way is I can think of this as taking the absolute value here of, well, -18 over 3 is going to be -6, and that's just going to give me 6, right? So that's one way we can do this. Or we could follow this rule here, right? So we could say this is going to be equal to the absolute value of -18 over the absolute value of 3, and that's going to be the same as positive 18 over 3, and that is 6. Okay, so we get the same result here. And actually, this shouldn't surprise us because we can think of division as actually the multiplication of like a reciprocal, right? So we can convert division into multiplication and then just use the previous rule. So let me show you how that might work, right? So if we have this here, we can think of this as the absolute value of -18 multiplied by the reciprocal of the denominator. The denominator is 3, so the reciprocal of that is 1/3. And now this is a multiplication operation, so we can use the first rule, right? So this is basically the same as the absolute value of -18 multiplied by the absolute value of 1/3. And again, that's just going to give us 18 times 1/3, which is 6. Okay, so these two rules are basically the same thing if you interpret division this way. Let's look at the next one. This final rule is what we call the triangle inequality. It has its own special name, and I'm not going to really explain where that comes from right now, but I plan to do another video where I delve a little bit deeper into this and show why we call it that. But for now, we can just sort of look at this rule, and it's actually a little bit unintuitive. We might expect the absolute value of a plus b should equal the absolute value of a plus the absolute value of b. But this rule is telling us that's not always true. Sometimes it's true, sometimes it's equal, but sometimes you'll get a less than sign here. Let's show you an example to sort of explain why, right? What if I have the absolute value of 2 plus 5? Okay, what's this going to be? Well, 2 plus 5 is 7, so the absolute value of 7 is just going to be 7. Okay, that's all right. What if I have now the absolute value then of 2 plus the absolute value of 5? Well, again, this is going to be a 2 plus a 5, so I'm just going to get a 7, right? And so what we have here is an equality sign. These are equal, okay? That's sort of what we would intuitively expect. But what if I change things a little bit? What if I have the absolute value of 2 plus the plus negative 5 in here, and I take the absolute value of that entire expression? What's this going to be? Well, I know that 2 plus negative 5, well, that's the same as 2 minus 5, and that's going to give me a negative 3. So this is essentially the absolute value of negative 3, and that will be 3. Okay, so now let's try and separate the terms. I'm going to have the absolute value of 2 plus the absolute value of negative 5. What is that going to be? Well, that's going to be 2 plus 5, and that's going to equal 7. Okay, so this is equal to 7. So now what do we have? Not equals, right? This is going to be 3 is less than 7. That's where this less than sign is coming from. And let me try it the other way around. So what if I do instead, well, let's do negative 2 plus negative 5. What do I get here? Okay, so I'm going to do this. Well, negative 2 minus 5 is negative 7. So this is the absolute value of negative 7. That is 7. All right, well, now let's try separating the terms. The absolute value of negative 2 plus the absolute value of negative 5. What's that going to be? Well, that's also 2 plus 5. That is 7. And so once again, I have equality here. What changed? What's going on? Well, what changed is, if you notice here, 2 and 5 are both positive. Equals. They share the same sign. Negative 2 and negative 5 share the same sign. Equals. 2 and negative 5, well, those are different signs, and so now we get this less than. Okay, so that's sort of what this rule is actually talking about. So you get an equal sign here if A and B share the same sign. You get a less than if A and B have opposite signs. Okay, so that is what we call the triangle inequality. Let's take a look at one last thing, a special little operation we can use here. This is a distance formula that's allowing us to calculate the distance between any 2 points, A and B. And the way you do it is you just subtract the 2 points and then take the absolute value. And this is showing us that it doesn't matter what order you do this operation in, you will always get the same distance. And that's because the absolute value is going to throw away any negative sign, right? Let me give you an example. So here's a little number line. Let's say this is the origin, and let me put a point here. Let's say this is negative 2. Let me put another point here. This is 5. Well, what's the distance going to be between negative 2 and 5? Well, I think just looking at this, we should expect this distance to be 7 units, right? Whatever units we're using here. So let's try using the distance formula and see if that works. Okay, so we're going to use the distance formula. We're going to take the absolute value of, well, let's start with 5 minus negative 2. Okay, what's that going to give us? Well, this is going to be 5 plus 2, essentially, so that's going to be 7, and taking the absolute value of 7 is just going to be 7, okay? So that works. Let's see if we do, we flip the order here. We have negative 2 minus 5. We do the absolute value there. What's that? Well, this is going to be now negative 2 minus 5, that's going to be negative 7. Taking the absolute value of that is 7. Okay, so yes, it works. We're going to get 7. Okay, so perfect. The distance here is exactly what we expected. Let me show you another example. Let's try another number line here. Origin, let's do a position here. Let's say this is 1, and let's say that this is 4. Okay, what's the distance between 1 and 4? Again, sort of looking at this, I think we should expect a distance of 3. Okay, let's use the distance formula. So let's do 4 minus 1. Absolute value of that, well, that's going to be, well, this is going to be 3. Absolute value of 3 is just going to be 3. Okay, so there we go. We're getting 3. Let's swap the order here. Okay, so let's take the absolute value of 1 minus 4. What do we get here? Okay, so 1 minus 4, well, that's going to be negative 3, but we're taking the absolute value. So again, that is just going to give us 3. So once again, it works. And let's do one more example where both numbers are negative, just to verify here. So let me do this. Let me say that this is now the origin, and let's say we're at negative 1 and another point here at negative 5. Okay, so what's the distance going to be? Well, probably we should get a distance of 4. So let's just verify with the distance formula. We'll take the absolute value, let's say, of negative 1 minus negative 5. What's that going to give us? Well, this is the same as negative 1 plus 5, so that's going to be 4, isn't it, right? Taking the absolute value of 4 is just going to be 4. Okay, so that's what we expect to get. Let's do the reverse here. So we're going to have negative 5 minus negative 1. Okay, what's this? This is the same as negative 5 plus 1. So that's going to be a negative 4. Taking the absolute value of negative 4 gives us positive 4. So the distance formula here works because we're not assuming that A and B is an ordered pair, right? So we're not assuming that A is less than B. If that's true, we could just do B minus A. We'll get the answer every time. But if we don't assume the order here, then that's why you have to take the absolute value, because you're not exactly sure which one's going to be bigger or smaller, so you might get a negative number. But you want to throw out a negative number because distance is never negative. It's only ever positive. Okay, so that's absolute value. The operation itself is pretty straightforward. And there's a few important rules and properties here. When you multiply, divide, add them together, it's worth keeping in mind. Okay, next video, I'm going to delve in a little more to that triangle inequality, show you why it's called a triangle inequality. Hope to see you there.